Nitrous oxide is a greenhouse gas that comes from various sources, so it can come from naturally produced or through anthropogenic activities. So it's a gas that's of concern because it has a global warming potential that's around 300 times that of CO2. For nitrous oxide emissions, agriculture accounts for about 75% of the total N2O emissions for Australia, and around 33% comes from management of agricultural soils, which includes the use of synthetic fertilisers. If we started with an application of, say, urea, which is a commonly used fertiliser, that first becomes hydrolysed to ammonia and ammonium. And then the processes that lead to production of N2O are nitrification, which is the oxidation of ammonium to nitrate, and then denitrification, which is the reduction of nitrate through to nitrous oxide and then N2 gas as well. So both processes can lead to emissions of N2O. It's one of the gases that's seen that can be reduced relatively easily. Things as simple as reducing nitrogen application rates. To reduce losses, we need to reduce inputs and make the system much more efficient. If you think that nitrogen use efficiency may be around 50 or 60% of applied nitrogen, we're trying to reduce what is lost or not taken up by the plant, and through that process you can then reduce N rates and maintain productivity. One of those ways is with these nitrification inhibitor products that can be applied to fertilisers. So what those products do is after you have ammonium, they prevent the oxidation of that to nitrate. So it slows down the release of ammonium. So there's more ammonium available in the soil for the plant to take up, less nitrate available for leaching losses or for denitrification to occur. In our studies that we've done, we do a lot of lab work where we look at soil, the impact of the inhibitors on different soils, and we find that in many instances we do get a reduction in N2O emissions, and it can range from essentially zero in some soils to up to 95% reduction in the level of N2O that's emitted with the use of one of these inhibitor products. In systems where you had high emissions, the cost almost is going to justify itself. You can then buy less fertiliser at a premium cost but reduce your emissions of nitrous oxide. So the production that you'll get could be higher in those systems.